Hi everyone. In this video, we are going to do a simple interest. This is the first video for the finance part in Unit 2. We are going to have videos for simple interest, compound interest, annuity. So minimum 3 videos. Let's look at the first one, simple interest. You can see on the screen, we have this simple interest formula where I represent the dollar amount of the interest. So let me write down in here. This is the interest amount. And P represent principal, which is your deposit or the amount you borrowed. And R apparently is interest rate. And T is time. Okay, first of all, this is a simple formula, but no matter how simple it is, we want to understand the meaning of it. Actually, we want to make sense out of it. Formula is not just a bunch of letters and numbers in the equation. Until you understand the meaning of each variable in it, it's not going to stay with you. So that's the whole point of learning, right? We want to understand it. Okay, let's make sense out of this formula. I'm going to do that using an analogy in real life, which everybody can understand. So let's say you drive your car at 60 miles per hour, constant speed. Okay. Now let's look at some numbers between the distance you travel in miles and the time you drive in hours. So this is like distance. And this is time. Again, this is time is in hour, distance is in mile. Let's say if you drive 1 hour, that's going to be 60 miles. And 2 hours, 120. 3 hours, 180. If you do 10 hours, let's say you drive like a robot, always at a constant speed and never stop, never take a break. Just make these things straight, easier. 10 hours is going to be 600 miles, right? I guess you can see these numbers, and we can continue if we want, but it's not necessary. Now let's look at the relation between these two columns of numbers. For the time, from 1 hour to 2 hours, that's a double. That's a double. And correspondingly, the distance goes from 60 miles to 120 miles, which is also a double, right? So one side doubled, the other side doubled too. Now, how about you do 1 to 3? That's a triple. The other side, 60 to 180 is a triple. This is true for any pair of numbers. So if you go, for example, from 2 to 10, that's 5 times as long, right? In terms of time of driving. How about the distance from 120 to 600? That's also 5 times, right? So what is the relation between time and distance? One side increases, the other increases too. One side doubled, the other side doubled too. We call that relation proportion. So we say distance is proportional to the time. And how do we represent that? That is proportion relation. And everybody learned the distance, speed, and time formula, probably likely in elementary school. So if I use D to represent distance in miles and T represent the time in hours, the formula becomes this. Distance equal to 60 times T. Let's double check. T equal to 1 hour, 1 times 60, 60 miles. T equal to 2 hours, 2 times 60, 120. 3 times 60, 180. 3 hours, 180. If you drive 10 hours, 10 times 60, 600. Basically, this formula represents all of this, right? And continue to be true for any number you put in here. So notice that this distance D is proportional to T. We write D on one side and t on the other side, and we have number in between. Now, let's look at a second example so that we can establish this mathematical model for the proportion relation. Now, the second one is a totally different scenario, and let's look at the conclusion. So this time we go shopping. So we buy beef, which is a good one. So let's say it's $10 per pound. Now let's look at your total cost in dollar and weight, how many pounds you want to buy. This is in pounds. So we want to know the relation between the total cost and the weight. So let's say you buy 1 pound, $10, 2 pounds, $20, again 3 pounds, $30. You have a big party coming, you buy say 20 pounds, $200. You know, all of these numbers are true, right? Again, let's look at the relation between these two columns. For the weight, from 1 to 2 is double. How about the total cost? It's double too. How about you go from 2 to 20? That's 10 times as much, right? Weight. How about total cost? Also 10 times as much. So what happened in terms of relation between this total cost and the weight? We have exact same thing going on, just like between distance and the time. One side double, the other side double. One side is 10 times, the other side 10 times. So we can say the total cost is proportional to the weight. So how do we represent this relation between total cost and the weight? Let's use C to represent total cost and W to represent weight. Can we write the formula as this? Say C equals 10 times W. Is that still true? W equal 1, weight is 1 pound, 1 times 10, $10. 2 pounds, $20. 20 pounds, $200. So still true, right? Now the most important part is that mathematically, these two have exactly the same structure, even though they totally have different content. One is shopping, one is driving, right? But as long as they have these two variables, which have the same proportion relation. The way we represent this proportion relation in mathematics is the same. We just put one variable on one side, the other one on the other side. In between, we have constant number. And this constant number doesn't matter. Even if this is $20 per pound, this relation still holds. Just like this. If you drive at 90 miles per hour, this relation is still true, as long as your car can do that, as long as you don't get caught by the police, right? It's still true. So in other words, in mathematics, we don't care the specific scenario. We just care about the structure, mathematically, how to represent proportion relation, which is one variable on one side, the other variable on the other side, and there's a number in between. That's how we represent proportion. Is this relevant to our simple interest? 100% relevant. So let's take a closer look at this simple interest formula. Is that true that the interest amount is proportional to the amount you deposit? In other words, is that true? The more you deposit, you expect more interest? Otherwise, who will deposit in the first place, right? The banking system will not work. So apparently, this interest amount is proportional to your deposit principal. So we put interest amount on one side, principal on the other side. Now let's look at interest rate. Now imagine you have two separate accounts. You deposit same amount of money. You deposit your money for the same amount of time. Only difference is that one bank gives you higher interest than the other one. So which one will give you a higher amount of interest in the end? Apparently, the bank who gives you the higher interest rate, right? In other words, everything else being equal, the higher interest rate you get, the higher interest amount you get. So interest amount is proportional to the interest rate. That's why we put interest amount on one side, interest rate on the other side. Now I guess you can guess what I'm going to say next for T, right? Again, let's assume you have two separate accounts, and where you deposit same amount of money, you get the same interest rate. The only difference is that in one account, you keep money in there for longer time than the other account. So what happened to the interest amount in these two separate accounts? I'm sure you will say that the one that you keep money in the account for longer time will give you more interest, right? So interest amount is also proportional to the time. So interest amount on one side, time on the other side. So we put T in here. As a result, interest amount is proportional to all of these three. So what about the number in between? We're supposed to have a number to be a proportion in this model, right? We do have a number here. The number happens to be 1. So 1 times that, we don't have to write 1 because it won't change any result. So that's our formula for simple interest account. Okay, let's move on. In using this formula, there's something you need to be careful because that's where the first common mistake comes in. When you use this time, you have to make sure your time is consistent with interest rate. So T and R have to be consistent. So what does it mean consistent? Usually, most often, you will hear annual rate, right? Yearly rate. Yeah, that is true. That is the most popular period for the interest rate. But there are other interest rate like quarterly rate, monthly rate, daily rate, weekly rate. We even have overnight rate, but that's not for average people. But nonetheless, they exist. Okay, so you must be sure your time is consistent with interest rate. In other words, if you have annual rate, the time has to be in terms of, say this is R, and this is your T. Your time has to be in terms of years. Even though your given months, your given days, you have to convert to years before you can use that formula. That's called being consistent. If your annual rate is daily rate, and your time has to be in terms of days. Again, they have to be on the same unit in time to be consistent. Otherwise, you could make some really, really ridiculous mistake. Okay, move on. Let's look at our first example. Now, actually, before that, let's relook at this formula. And there's some good news here. Say in this simple interest formula, all we have are 4 variables. In other words, one formula, 4 variables. It's like one equation, 4 unknowns. For a single equation to be solvable, you can only have one variable in it. So as a result, in any question, in any simple interest question, they can only ask one of these 4 variables and give you the other 3. So we can also say that there's only 4 questions they can ask because you only have 4 different variables. In each question they ask you, they have to give you the other 3 values for the other 3 variables. So that's a general scenario. So let's look at our first example. And this is the very first one. Usually the first example is the simplest. Let's take a look at it. Suppose your city is building a new park and issues bonds to raise the money to build it. You obtain a $1,000 bond, and that pays 5% interest annually, so annual interest rate, that matures in 5 years. This is how the bonds work. Okay, basically you lend money to the government and they pay you interest. And sometimes they pay you annually, sometimes they pay you every half year, it depends. Most of the time it's going to be every half year. But nonetheless, they pay you interest. One is a mature day, and in the future, in this case 5 years, they give you back your original principal, in this case $1,000. So that's how bond works. Now, the question is how much interest will you earn? So apparently this is a simple interest problem. By the way, how do I know that this is a simple interest problem? Because for any compound interest or compound interest based financial product, they have to mention compounding frequency. How often your account is compounded? For example, compounded annually, compounded monthly, compounded daily. Savings account is compounded daily. So they have to mention how often your account is compounded. Otherwise, you can assume it is simple interest account. And this is the beginning of this finance part in the unit 2. I hope everybody look at the bigger picture when you answer these finance questions, because later on, after you learn all of these different formulas, nobody will tell you, hey, this problem is from a simple interest lecture. You just have a problem to solve. At that time, you have to determine which formula to use because there are many formulas. That's why we need to understand what kind of problem we have, not just plug in numbers because we have simple formula here. Okay, now, since this is a simple interest formula, we expect to be given 3 numbers. Solve for the first one. Let's look at what is given. We are solving for interest. That means we are solving for I. That means the other 3 have to be given. So I equals principal, which is 1,000. You lend the city government $1,000, and they pay you 5% annually, and times time. Time has to be in years because this interest rate is annual rate. So we happen to have time in years. So we don't need to change it. We just put it in here. So everybody can do this simple calculation. 1,000 times 0.05. Usually we convert the percent to decimal. Times 5, that's 250. So at the end of the 5th year, you earn totally $250 as interest, and you get that $1,000 back. Move on to the second example. Find the interest amount and future value. Future value is also called account balance for the loan. That means you borrow money this time. So the principal is the amount you borrowed. When you return the money when it is time, you have to return both the amount you borrowed plus interest, right? The whole thing is called account balance or future value. So we have 2 questions basically. First, this is simple interest. Again, they didn't mention how often the account is compounded. So principal is 42.52 times interest rate times 10 months. Again, here you have to be consistent. It's annual rate. This is not a year. We have to convert to year because for the whole year, you need to pay 6%. If you don't divide by 12, if you times 10 directly, you overpay by 12 times as much. And because this is 10 months is supposed to be less than a year, you're supposed to pay less than 6%. Without the dividing by 12, you not only pay 6%, you pay 10 of those. So that's way overpaid in interest. And nobody want to borrow the money to pay this much. You're going to bankrupt really, really fast. So now let's do the calculation part. 42.52 times 0.06 times 10 divided by 12. Now, I'd like to say something about the calculation part. It's not that we just go ahead and do the calculation. Whenever we deal with money, we want to make sure we don't want to make too much rounding error, because this number, 4,000 something, is very small in real life, especially when you deal with company's money, not your money. It's usually in terms of tens of thousands. That's still kind of small. For Walmart, always millions almost. So any rounding error in the middle of calculation, for example, in this case, if you do this division, you get a decimal number supposed to be a multi-decimal digit number, maybe countless decimal digits, right? Sometimes you have to round it. You will have a rounding error because if you have countless digits, there's no way you don't round it. So if you do this part first, and you get rounding error, no matter how small that rounding error is, when you multiply by a huge number, your rounding error is also huge. Let me give you one scenario because I taught business mathematics before. Just give you a real life scenario to see how terrible this is if people don't pay attention to rounding error. And many people do not pay attention to that because they used to have 2 decimal digits, 3 decimal digits, just keep doing that. Now imagine if you are a purchase person for Walmart and you're supposed to buy, say, 20 million pens for Walmart. Buy pens, right? Like a back to school period, right? You need 20 million. 20 million is not a huge number for Walmart for millions of students. Now, let's say you didn't pay attention to rounding. You round off half cents. Half cents is gone for each pen. Now half cents is this 0.005, right? Dollar, because 0.01 is 1 cent. This is half cent. Sounds really small. That's half cent, right? But don't forget, you buy 20 million of them. 20 million means add another 6 zeros. 1, 2, 3, 1, 2, 3. You just round up $100,000. Guess what? Next day, that job is not yours, and plus some penalty maybe. So make sure you pay attention to rounding error. We can control rounding error easily. You just need to know how to do that. In this case, we don't do this division first. We do all of these multiplications. And in the end, we do division by 12. So we only rounded using the final result. In that scenario, we can control the error. If we round it to the second decimal digit, no matter how big the number we deal with, the rounding error is always smaller than 1 cent. That's perfect. So let's do that. 4252 times 0.06 times 10 divided by 12. So I do everything in one step. So we got $212.60. The rest are zero since we only need a second digit for money. So this is the exact number. We don't need to do rounding because the rest are zeros. So these are our exact number. And future value, this is the interest we need to pay back. And the future value or balance, let's say future value equals the amount we borrowed plus the interest we need to pay equals, so I still have this number on the screen, so I just add 4252 to it. So we get $4,464.60. This is the exact amount you need to pay back. Okay, another one. This is the exercise problem. So we do this relatively quickly because this is the exact same scenario, just different numbers. So we calculate I first using principal times interest rate times time, which we need to convert to a year. This is the case actually. 8 divided by 12 is 2/3, is 0.66 forever. You have to round it. And so that's why we do all this multiplication and do division in the end. So 10,389 times 0.092 times 8 over 12. Make sure you convert percent to decimal correctly by moving decimal point to the left 2 places. So we get 10,389 times 0.092 times 8 divided by 12. So this equals $637.19. So we round to the second digit. Since the third one is smaller than 5, we just truncate it. Now the future value, the total amount need to pay, equals 10,389 plus interest 637.19. Now I just need to add this 10,389. So let's see, we got 11,000 $26.19. This total balance at the end of the period. Yeah. Let's move on to the next page. Another example here. Remember in the beginning, right after we look at the formula, we mentioned that there are only 4 questions they can ask, right? So the previous 2 example and exercise, basically we find the interest amount, right? Now this is a question, we find the principal. Present value, right? Principal also called present value because that's how much you have now, or how much you borrowed right now, or how much you deposit right now. And later on, it will generate interest. Round to the nearest cent. Always pay attention to the requirement. Sometimes they ask you to round to the dollar. So always pay attention to that. So we are given this information, simple interest rate. So we know this is simple interest account. As soon as we realize that, write down this formula. And we have to be given 3 numbers. That's why we are given 3 numbers. So we're looking for P principal. I has to be given this interest amount. So 69.25 equals principal times R and T. R is 10% and T is 60 days. Again, have to be consistent. This annual rate, these days, we have to convert days to years. So divided by 360. Now, let me mention this quickly. In this, all of this financial product, and we use 360 days for a year, not 365. That's not a mistake. So you need to pay attention to that. Unless we are clearly told to use 365 days per year, we use 360. Again, this is called the banker's rule. For whatever reason, that is outside the scope of this course, but they use 360 days. Now, we're solving for P. In the end, if we do this part, we don't do it, by the way, because it is a countless digits. If we do this part, it will be a single number in the end. To solve for P, we need to divide by this number. Imagine if you have equation like this, 10 equals 2x. How do you solve x? Divided by 2 on both sides, right? So that x equals to 5. You know, that's how we solve it, right? Same thing here. This will be a number. So we need to divide by this whole thing on both sides. So P actually equals 69.25 over 10%. I'm going to use a parenthesis. 10% is 0.1, by the way. 0.1 times 60 over 360. Now we let the calculator do the calculation. Calculators don't do any rounding because they have enough memory to keep thousands of decimal digits. They just don't display that many. So look at how I do this one. This way we don't have any error beyond 1 cent. Okay, 69.25 divided by, make sure you use parentheses so that the calculator will do this part of calculation first to get a single number, then they do division. Without parentheses, the calculator will use this one divided by this, and then using the result multiplied by this. That's totally wrong. Order of operations. So divided by 0.1 times 60 divided by 360. Anything below a bar means divisor, okay? Times 60 divided by 360, close the parentheses, and then equal. Now this makes sense. $4,155. This is exact. This is exact. Round to the cents. Even though the whole dollar, you have to have the 2 digits to represent. You have up to cents. It happen to be 0. Could be any other number. This just happen to be 0. Because we didn't do any rounding here. If you do this part first, you got 0.0166666 forever. And in that case, no matter what, you're going to have running error. Okay, we found the principle. That's it. And now let's move on to the next one. And see this one, we skip this exercise problem. Basically, the exact kind of problem. We just have different numbers. Now, let's look at the next example. find the simple interest rate. See, I have another question. Simple interest, I equal to PRT. This time we're looking for R. So we should be given the other three. Interest amount, 174.17. Principal, 5,500. Times R times T. T is 120 days. Again, divided by 360 to convert it to year. And hopefully by this point, you can see that this is the exact same kind of problem. So we divide the result of these three numbers on both sides, because 5,000 times 120 divided by 360, it will be a number. Whatever the number is, we just don't do it first. We want to calculate to the whole thing. So R equals 174.17, 5,500 times 120 over 360. Now we expect to get a decimal number because it's the interest rate. 174.17 divided by parentheses 5,500 times 120 divided by 360 equals, yeah, that's exactly expected, 0.095 and a bunch of zeros and 1. Now we have enough digits. I don't have to copy the rest because this is the interest rate. All I need is a move decimal point to the right for to get a percent. So this basically 9.5001%. Usually for interest rate, we just have one decimal digit in percent. Sometimes you have two, but no more than that. Let's assume we need one, say, not assume, we require that 1/10 of percent. In percent, you need a 10th place. 10th place is the first decimal digit. So this is 0, we just truncate it, we get 9.5%. So this is the final answer. Now let's look at our next example. This exercise problem, or exact same kind of problem. Another example, find the time. See, we need to find the time now in this formula. Still simple interest problem. So I equals PRT. Interest amount is 120 and round to the nearest day. We need a whole number basically. Principal is 2,000 and R is 12% and T. Now basically T equals, at this point you know what to do now. 120 divided by this is just one number actually. 2,000 times 0.12 equals let's say 120 divided by parentheses 2,000 times 0.12, 0.5. The rest are zeros, 0.5. So is this final answer? The answer is no. The reason is that T and interest rate are always consistent. This annual rate, the T, whatever number you get is in years. And the other is days. That's why after you get this number, this time in days, just multiply it by 360. So this is 180 days. This is the final answer. We don't need to do rounding in this case because we get the exact number. And in case, actually it's more typical, you get a number for years with many, many digits. In that case, you make sure you keep enough digits so that your rounding error is no more than 1 day. If your rounding number is more than 1 day, your answer is definitely going to be wrong. Okay. So usually to be safe, I like to write it down here. You want to have, in any middle step calculation, you want to have 6 to 8 non-zero decimal digits. To be safe, 6 to 8 digits means you're good for anything between $1 million to $100 million range. Even you get to that range, your error going to be small enough, several cents, several dimes, and you're not going to lose your job because of that. But if you round off several say several $100, maybe $50, if that happen often, you're going to lose your job. It's not just money, because you make the whole accounting a big mess if that happens. So now what is called non-zero decimal digits as the illustration? Say 0.0256. This is a non-zero decimal digit. This is a zero, don't count. 1, 2, 3. This only count as 3. You need 6 to 8 non-zero decimal digits just to be safe. Why we pick 6 to 8? Because for average person, $1 million up to $100 million, that's really, really big money. If you have to deal with the amount of money beyond that, billions of dollars, you're not going to do this calculation yourself. You're going to have your secretary, you're going to have other accountants do it for you. Okay, now let's look at this one. This is the exercise. We do this one because this is kind of in terms of days. We don't have this kind of examples very often. So let's do it one more time. So we still find time in this simple interest account. So I equals PRT. I is $831.25. And P is 15,000. R is 9.5%, and we're looking for T. And say basic T equals 831.25 over 15,000 times 0.095. And let's do the calculation. This time I'm going to show you the number, but I'm not going to write down the number. Maybe I'll write it down just to illustrate that why we have 6 to 8 decimal digits in the middle step. $831.25 divided by parentheses 15,000 times 0.095. Yep. So I'm going to write down this number 0.58. Totally, let's write 8. 1, 2. The rest are 3s, so 6 3s. This many days. And then we use this many days times 360 to see what we get. Okay. So I'm going to retype this because actual digits on the screen is more than that. They have counted digits, just don't display it. So I'm going to retype this. Wait. 333. 8 non-zero decimal digits, right? Convert this one to days times 360. What do we have? What we have is 209.999, so many nines. We need a whole number. You know, this is 210 for sure. 210 days. Now, imagine you round it. Some people just like to have 2 decimal digits. Sometimes they have one more 3. But let's say they have 2 decimal digits. It would be 0.58. Then times 360. Guess what? 208.8 round 209. You round 1 day off. Now 1 day off for big money borrowing, and that 1 day off could mean hundreds of dollars interest. And the big banks like JP Morgan Chase, they don't just do business with one client. Globally, they have millions of clients. Think about many millions difference just because it's 1 day. Okay, now the best way to do that, actually, we don't even write down this. Now, let me do that quickly one more time. 831.25 divided by parentheses 15,000 times 0.095 close parentheses and equal. After you have this on screen, just times 360 directly. So without any rounding. That's why you get the exact amount. Because there's no rounding. They keep thousands of digits. Okay, move on to the next one. So now we have this application problems. And we also have 4 questions because they can only ask 4 questions. And this is not different from all of the examples we did so far. It's just that they put these numbers so that it become a story. So-called application problems. The most important part is that you need to identify what kind of account you have. Again, later on, we're going to have a compounding account, we're going to have annuity, we're going to have mortgage, we're going to have a loan payment. Just make sure you look at this real important part first so that you know which formula to use. Now let's look at our first one. Hank Wilkins invested $5,200 in a mutual fund containing bonds. Find the rate given that he earned 257.83 in 221 days, 210 days. So what kind of account do we have? We have simple interest account. Again, no, because nowhere did they mention how often the account is compounded, right? So this is simple interest. And we are looking for the rate. So we have to be given the other three. So interest amount, let's say 257.83. Principal is 5,200, how much you put in. And we're looking for the rate, time is 210 days divided by 360 to convert to years. You can see this is all the story, right? R equals 257.83 and divided by 5,200 times 210 over 360. So let's do the calculation. 257.83 divided by parentheses 5,200 times 210 divided by 360. Yeah, everything is good. I got 0.08499. And we need interest rate. Usually we keep one decimal digit in the percent. So we move it 2 digits to the right. We got 8.499, so 8.5%. So that's our final answer. Next one. Haggerty Telephone earned 150 in interest on a 20,000 deposit in an account paying 3%. Find the number of days that the fund were on deposit. So we need time in this simple interest account. So I equals PRT. Plug in numbers. Interest amount is 150. The amount of deposit 20,000 times interest rate, which is 3%, and times T. We're looking for T in days. So T equals 150 divided by 20,000 times 0.03. So I'm going to do this using calculator and then multiply by 360. 150 divided by 20,000 times 0.03 equals, yeah, that quarters of 360 must be 90. So 90 days. Make sure you write down the units because this formula, the right answer is in years. Without units, people would think this is wrong, something wrong. Okay, third one. Webb's Pancake House earned 600 interest in 240 days from an investment that paid 3.5%. Find the amount initially invested. So we are looking for principal in this case. Everything is similar, just application problem. I equal to PRT. Interest amount is 600. Find the amount invested. We are looking for principal. Rate 3.5%. Time is 240 days. So we just divide by this whole thing on both sides. So P equals 600 divided by 0.035 times 240 over 360. And 600 divided by parentheses 0.035, double check my typing, times 240 divided by 360. Yeah, everything is good. equals, we get $25,714.29. How do we know this is right? So usually, if you're sure your calculation has no problem, you don't need to double check. But for the sake of this demonstration, let's do it once. We want to check if this is right. If this is right, in 240 days, paying 3.5%, we should get $600. Okay, very, very close to that because we round to the cents, almost exact. Let's do that. Interest amount equals principal, 25,714.29 cents times 3.5% times 240 over 360. Let's say if we get $600 and 25,714.29, yeah, times 0.035 times 240 divided by 360 equals, yeah, almost no error. So that's right. That's the right answer. The last one, let's look at this one. Anita Toombs about a new computer system. To pay for the system, she borrowed $57.30 from the credit union at 8.4% of interest rate for 115 days. Find the interest amount paid. So this is a very simple, straightforward problem. We're looking for this I. The reason I use this one as a example here is that I want to make sure people know how to convert the fraction percent to decimal correctly. Okay, now we're looking for I. Principal is, oh, here it is. 5,730 times 8 and 4/5% times 115 days over 360. Now let's look at this separately so that you pay attention to that. 8/4, this is smaller than 9 for sure. So this whole thing smaller than 9% to make sense. And 9% is 0.09. That means after you convert this to decimal, it has to be smaller than 0.09 to be right. Now, how to do that? Look at the fraction first, fractional part. 4/5 is 0.8. So this one become 8.8. You still have this percent symbol. Move it 2 digits to the left, 0.088, which is slightly smaller than 0.09. This makes sense. This is right. So I equals 5730 times 0.088 times 115 over 360. Now it's time for the calculator to work. 5730 times 0.088 times 115 divided by 360. And that's all. So we got $161.08. Make sure when you round it to the cents, you always look at the third decimal digit to do rounding. And that's it. I'll see you in the next video.